Everyone, my name is Chris Helms and I'm the creator of HearthStoneSimulationOnGolem. This project is intended to allow individuals to create decks in Hearthstone and then run numerous simulations against them to determine statistical data and deck behavior that might be helpful in tweaking and modifying their decks. This video is intended just to be a quick and dirty run through of how to run the requester script on your machine. If you're looking for things like details under the hood about the application, concepts behind it, how it works, all of that, I've created a PowerPoint presentation that I'll link to in the description of this video. So without further ado, let's run the application. So I'm going to move over to the terminal session, and you can see that I'm already in the HearthStoneOnGolem requester folder here. So the first thing I'm going to do is build our project with npm run build, and that'll compile our tight script and create all the directories we need to run the application. Once that's complete, I'm going to jump over to Visual Studio Code to show you a little more. And so here in Visual Studio Code, we can see what's defined as, or what I call, an in file. So an in file is the data that we're going to pass the application so it knows what to run with whenever it runs the simulations. Here this is in JSON, and you can see there's three main parts to it. There's a player 1, a player 2, and a number of games. Player 1 and player 2 are very similar. They describe each player's deck and each player's strategy. So you can see within the deck that I have named a list of cards here that are going to be used for player 1's deck, and then for strategy I have decided a strategy that player 1 will be using. The cards here don't have to be in any particular order. They will be switched for every simulation run, but they do have to match class names described in the provider repository. You can check that out a little later for more details on that. And then you can see that player 2's are very similar. Finally, we have the number of games property down here, which is going to tell the requester how many games or simulations we want to run on these two particular decks. So now that we've gone over the in file, I'm going to copy that to the input directory, and that's located in distribution input. And once that's copied, I'm going to rename it. The application or requester script expects that the file is named specifically, so we have to remove this example piece here, and if you want to try it out for yourself, you'll have to do that as well. Once that's all in place, we're ready to run the application. And so prior to this, I've already set up my computer to run as a Golem requester, so that involves running the YAGNA service, exporting the API key, and setting up for payments on the testnet. If you plan to run this yourself, you'll have to do those things as well. But without further ado, let's jump into the actual running of the application. So here we can just run it with build dist and then index.js, and I'll hit enter. You can see the number of simulations that's going to run is 20, just as we described in the in file, and you can see Golem publishing demands out on the market for them to be taken by providers. This section could take a little bit, so I'm going to jump ahead, and I'll see you when it's complete. So at this point, all of the simulations have completed, and we can talk a little bit about what happened behind the scenes there. So if we head on over to our infile.json again, whenever we ran the requester script, we specified that we wanted 20 games to run. And what that did was have the requester find 20 providers who were willing to simulate games for us. Each of those providers received the above information with both players' decks and strategies they wanted to use, and took that information and sent it into the game engine, where an actual game of Hearthstone was simulated using this data. Once those games complete, they each output a set of stats and a set of logs. The statistics give us useful data on numbers, basically, that the games output. So you can think of things like number of cards played, number of cards discarded, monsters played, damage done to heroes, etc., and of course who won. The logging outputs different moves, what exactly the game was thinking when it was making moves, what monsters attacked what other monsters, and those sorts of details. And so the output gives us a good look into exactly how the game was run. And so we can take a look into that. So those outputs are located in the distribution logging output folder. You can see here we have 3 different folders: full report, game stats, and logs. So let's take a look at a log first, and we'll look at the first game played, or game 0 here, by one of the providers. Here we can see that we've logged details about the game. So for example, the decks that each provider received, who's going to take the first turn, whenever the match starts, what exactly player 1 is doing, what moves they're looking at playing, what they played, what attacked what, and all sorts of things. So that's what this log is useful for, is following the actual moves that were made during the game. The other thing we can look at is a game stats file, and so this is the statistical output from the game, and this is tracked throughout the game. So whenever a monster attacks another monster or when a spell is played, those sorts of events are all tracked and details are kept on those events. And so here we can see that it's broken up into player 1 stats and player 2 stats, and then we additionally get a turns played number and who won the game. So here we can see player 2 won this game. If we take a look at the player 1 section here, we can see we're given the strategy that player 1 was using, and then we can see a couple useful statistics on the game itself. So things like cards that were drawn, cards that were played, monsters that were killed, fatigue damage taken, everything like that. And the goal of these statistics is to help you understand how your deck is working against the other deck, and things you might need to tweak to get better results. So for example, if you were playing a mill deck or something like that, you might want to look at the cards discarded, cards played, cards drawn statistics, because those are going to tell you whether or not you're running a good mill deck or not. And so every simulation run, as you can see over here on the left, gives one of these statistical outputs. So we ran 20 games, and as you can see here, there are 20 statistical outputs for those games. As a final, more useful report, the requester builds what's called a full report. And the full report takes into account all of those game statistics to give you a more in-depth look at what exactly happened over those 20 games. So when we're looking at this game stats output, we're only looking at a single game. But if we open up a full report, we can see statistics collected over the entirety of all those games. The build of this report is very similar to the statistical report. So since it uses those same data points, it's going to look kind of similar. But here in the full report, we can see something like cards naturally drawn and then 3 numbers. What these numbers represent is the minimum, average, and the maximum. And so here we can see a little more aggregated data compared to a single game, and this just gives us a better overall view of how our deck performs over time, because each game is different based on how the deck itself is shuffled. We can also see how often each player won, so we can see here the player won 8 times, and then if we scroll down we can see player 2 won 11 times, and then we could probably assume that a draw happened as well. So if we scroll down here, we can see there were 19 games played. The win percentage is for player 1 is 42%, and the win percentage for player 2 is 57%. Now, you might have noticed that games played only shows up as 19, and yet we specified it to run 20 games. Sometimes the Golem network messes up, or sometimes the application we've written messes up, and so a game log or statistic file may not be returned for that particular game. And then whenever the requester goes through and aggregates all the data from all of those games, it skips over that output that didn't get created. So that's why we're seeing the games played as 19 here instead of 20. So if we head on over back to the terminal, we should actually see the output of which game was missed. Yeah, we can see it down here in the bottom. So JSON for file stats failed to parse for game stats output 18. So that provider most likely had some form of issue. And if we were to go actually look at those logs, we would most likely see that game 18 has nothing in it. And so that's why we're only seeing 19 games on that final report there. And that about wraps up this quick and dirty presentation on how to run the HearthStoneSimulationOnGolem requester script. I highly recommend looking into the presentation that I'm going to link in the description, as it goes into a little more under the hood details. And for anyone who wants to use this application seriously, you'll want to check that out, as it gives more information on how to build your deck and then how to define a strategy that makes a little more granular decisions on your deck specifically. So highly recommend checking that one out. Additionally, I'll link the repos to both of the applications here, the requester and the provider. Those provide details on how to set both of them up, as well as how to make modifications to the two of them, really to cater the application a little more to your needs. Finally, I'll include a link to the Golem network project. I found this project extremely interesting. It's a decentralized cloud application. And so I thought it was really cool just to be able to run my application on computers all over the world and see it functioning in that way. So thank you, Golem. Again, thanks everyone who watched this presentation. I really appreciate it.